Hey programmers, welcome to the video. Let's directly jump into the today's Leetcode daily challenge. Today is 5th of October. We are solving. Today's problem is Pacific Atlantic water flow. Let's directly jump into the problem. So let's first understand the problem, and then we will explain. I will explain that how I am approaching this problem. So there is an M cross N rectangle island that borders with Pacific Ocean and Atlantic Ocean. Pacific Ocean touches the island left and top edges, and the Atlantic Ocean touches the island's right and bottom edges. Something like that. Okay, this is Pacific Ocean, this is Atlantic Ocean, and we have an island in between them. Parts into the grid of square cell, which we can see. M cross and integer matrix heights. Okay, where height of I comma j or r comma c represent that height above the sea level. Okay, so there is 5 means this cell is 5 level above the sea level. This is one height, means this is above the sea level. We have one height of block here. You can see 8.8 r comma c. The island receive lot of rain, so both side we have a big ocean, so lots of rain is there, and rain water can flow to neighbor cell directly, north, south, east and west. Understand this? If it is flowing north, south, east and west, that means we are considering for 4 neighbors. Okay, and then if the neighbor cell height is less than or equal to the current height cell. Okay, so let's say current x height is 5 and this neighbor cell height is 5, this neighbor cell height is 6, here it is 4, here it is 10. So it will not flow here because it's bigger. It's not flow here. It can flow here because it's more similar, and it can flow here because it's smaller. So small and similar height hai, then so we can like flow the water easily. Okay, let me remove the drawing first. Water written a 2D list of grid coordinates. Result of I is equal to r comma c, means we need to return a array of coordinates. Denotes that rainwater can flow from cell I and IC to both the Pacific and Atlantic Ocean. Okay, so let's understand this better with this example number 1. So in this example, if you can see here, so let's remove the drawing. Here we have this grid, and we have a heights of, this is the matrix of heights, and output is 0, 4, which is 0, this is 0, 1, 2, 3, 4. Let me mark this. Let me change the color first. Okay. So this is 0th row, this is first row, this is second row, this is third row, this is fourth row. Okay, this is 0th column, first column, second column, third and fourth. Okay, these are columns, these are rows. Okay, 0, 4 means this cell. Then we have 1, 3, which is this cell, 1, 4 and this cell. This is highlighted in yellow, so you can understand this highlighted in yellow is the answer. Okay, so from these cells you can see that if rain drops to this cell, it can flow to Pacific Ocean as well, and it can flow to Atlantic Ocean as well. That's the question is asking. Okay, so from the border we can see that this one we have a Pacific Ocean, so water can flow to Pacific Ocean. Yes. From 2 it can flow to Pacific Ocean. Yes. From this 2, yes. From this 2, yes. And from this 5, yes. So these 5 are rain is flowing to Pacific Ocean. Then we came to this border, so all these borders area also, like all the rains on these border cells can flow easily to Pacific Oceans, so we can mark them easily like these are the Pacific Ocean cells. Similar to, let me change the color, this is Atlantic Ocean, and water on this 5 can flow to Atlantic Ocean because it's nearby. So these borders can, like border cells water can flow to Atlantic Ocean easily. Okay, it can flow here or here. This is Atlantic Ocean, this is Atlantic Ocean, and this is Atlantic Ocean. Okay, and this is Atlantic Ocean. So here if you can see that these two cells, like cell number 5 and cell number this 5, from the border only we can see this bordering cell always can flow to Pacific and Atlantic Ocean easily. Okay, so we need to find all these cells here, or all these heights of cells where if rain drops, it can flow to Pacific and Atlantic, both the oceans. Okay, so let's understand for this 4, and let's first understand what all water can flow to Pacific Ocean. So let me choose the red color for that. Okay, let's look at this 2. So from this 2, can water go here? No. Can water go here? No. Can water go here? No. Can water go up? Yes. So this water can flow to 2, and this 2 to Pacific Ocean. So this is valid Pacific. It can go to Pacific Ocean. Let's look at for this 3. So this 3 can flow to 2, yes, and this can flow to Pacific Ocean. Can this go to 4? No. Can this go to 2? Yes, and then this 2 to it can flow to Pacific Ocean. Can this go to 5? No. Obviously, all 4 directions we have seen. Okay, so this is like marked as red, means it can flow to Pacific Ocean. For example, let's take this 4. This is 4. It can flow to 2, and 2 can flow to Pacific Ocean. So there is a path on which we can travel, and rainwater can follow the path and reach to Pacific Ocean. So that means this 4 is also marked as red. Let's look at this 7. So 7 is bigger than 4. 7 can flow to 4. 4 can flow to 2. 2 to Pacific Ocean. Okay. So similarly, we can mark each and every cell which can flow to Pacific Ocean. Like from this 4, we can go to this 3 to Pacific Ocean. From this 5, we can go to 3 to 2 to Pacific Ocean. Okay, and from each and every cell is marked. Let's see for this 4. From this 4, can it go to Pacific Ocean? Yes, it can go to this 4, then this 3, and then Pacific Ocean. Okay, can this 3 can go to Pacific Ocean? It can't go up, it can't go left, it can't go right, down, it can only go right. So it will reach out to 1, and if from 1, if we can't go to Pacific Ocean, then we can do, and if we are not able to do, then we will not be able to reach Pacific Ocean. Okay, so to know the answer of 3, we need to first find the answer of 1, because it's dependent on all these 4 directions. So 1 is more dependent. So let's find out first for 1. Okay, for 1, can we go to Pacific Ocean? It can't go up, it can't go left, it can't go down, it can only go right, and in the right only Atlantic Ocean is there. So it will go only to Atlantic Ocean, it will not able to go Pacific. So from 3, now we have the dependency on 1, and we can surely say that it will not be able to go Pacific Ocean. Similarly, for this 4, we have to find for, like from this 4, can we go to Pacific Ocean? It's dependent on this 2, and it's dependent on this 1, and it's dependent on this 3. It can't go 5, so it's not dependent on 5. So basically, each and every cell which is bigger, it is dependent on the smaller or equal cell to be resolved first. That 3 to be resolved first, 1 to be resolved, 2 to be resolved, so that we can find the answer of the bigger one. So we have to find the answer of smaller one first, and from that we can go to like bigger one, then bigger one, then bigger one, something like that. Okay. I hope you understood the problem. Let me clear the drawings. Okay, so if I mark it like what cell can go to Pacific Ocean, okay, and I can make a grid, okay, the similar size grid, 1 2 3 4 5, and then similarly here 5 cross 5 matrix, 2 3 4 5. Okay, so whenever from this cell, if we can go to Pacific Ocean, we will mark it as 1. This is a Boolean matrix, you can say. Okay, and if we can't go to Pacific Ocean, then we will mark it as false. Okay, so initially it's false, we will mark it as 1 because we can go from this bordering cell obviously. Then we can check for this cell. So this cell is 2 to it can go up like this. So this is also can go in passive question, this can also go, this can also go. Can this one go in passive question? So it can't go up, it can't go down, from this it can't go, right? So we will say 0. From this 3 yes, from this 4 yes, from this 4 yes, from this 5 yes we can go, and from this one there is no option, bigger 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 and down में, so then we have a Pacific this Atlantic Ocean. So for all these cells, if you clearly observe step by step, we can't go to Pacific Oceans. So we marked all the cells from which we can reach to Pacific Ocean. Similarly, we can make another Boolean matrix array from which we can reach out to Atlantic Ocean. Let me draw this first one. 2, 3. Oh, it's 5, 5 now. So let me create one more. Okay. So from each cell, we define that what all cell can reach to Atlantic Ocean. So this bottom cell obviously can easily reach to Atlantic Ocean. So we mark as 1. Okay. And now we can analyze for each and other cell. Like from this cell 3, can we go to Atlantic Ocean? No. No. It can go only to Pacific Ocean only. Okay? Because all these 2 routes are blocked. So this marked as 0. Similarly, this 2 is marked as 0. Okay. Similarly, these 2 are marked as 0. But remember, let's look at 6. 6 can go to 5. 5 can go to Atlantic Ocean. From 2 we can't go because it's bigger. We can't go here. It's bigger. We can't go here. It's bigger. We can't go here. Only option is to go to Pacific Ocean. So it's 0. 6 is 1. Okay. So from each and every cell you can do the exercise. From this 2 we can't go, so it will be 0. From this 3 we can't go, so it will be 0. From this 4, obviously we can go, like 4 to 4, 4 to 4, Atlantic Ocean. Okay. From this 3 to 1, 1 to Atlantic Ocean, so we can go. From this 4 to 2, 2 to Atlantic Ocean, so we can go, yes. Let's fill for these ones also. So this 1, 1, and it will go to Atlantic Ocean. From this 7 also, 7 is the biggest, I think, so it can obviously flow to anywhere. Like 7 to 1 and 1 to then Atlantic Ocean. Then this 5, 5 to 3, 3 to 1, so it can go also go. And this 4, so let's look at 4. Let me take one. Let me remove this one. Okay. So let's look at this 4. 4 can't go right, 4 can't go down, 4 can go only up, and 4 can go only left. So it will only reach to Pacific Ocean. So it will not be able to reach Atlantic Ocean. This is like Boolean array of Atlantic Ocean Boolean matrix. Okay. So now we understood one thing, ki all the cells which can reach to Pacific Ocean, all the cells which can reach to Atlantic Ocean. So now we can find the common between them, like what all cells are common, which can both reach to like or Pacific and Atlantic Ocean. So if rain drops on these cells, it can flow to Pacific, also it can flow to Atlantic Ocean. So let me mark the screen. So if you say 1 0, so it can't go, 1 0 it can't go, okay, 1 0. So first we will find this one. This cell can flow to both Atlantic and Pacific Ocean, Atlantic and Pacific Ocean. Both the Atlantic and Pacific, though both the matrix are showing 1, means this cell can reach. Similarly, this cell directly can reach, this cell can reach obviously. So wherever both the Pacific and Atlantic Ocean is true, we can say these cells can okay, reach to both of them. Similar to this, all the zeros are useless, all the ones are useless, like this one in 0, not matching, not matching, not matching. Okay, so these 1 2 3 4 5 6 7, so these 7 cells are there which can reach to both the oceans, and we have to mark the coordinates of them, like 0 4, So we have to output the 0, 4, 1, 3, 1, 4, 2, 2. These are the coordinates of these cells, these 7 cells we have to uh, need in the output. Okay, so problem understood, but how to solve that? So it's like similar to like covering the border and then going inside, something like that. So have you remember if we have solved that trapping rainwater 2 wali problem, which is like 3D matrix, and in which we trap some waters. So we have used like from smaller element to we go to bigger, then bigger elements. So I'm thinking of the similar approach. Can we go there? Okay. So let me remove this first. Okay. So we will like push this bordering. So obviously we have these borderings, this border for Atlantic. Okay, let's solve for one. So let's solve for Atlantic Ocean first. Similar algorithm we can solve for Pacific, and then we can take the union of both of them and end operation of both of them, and we can find the answer here. Okay, so finding answer is easy when we have calculated this and this. So we have to calculate the Atlantic Ocean Boolean matrix first. Okay, so to calculate, we already know that these all cells can go to Atlantic, these all cells can go to Atlantic easily. So we can push these and these rows in our system. Okay, so we can mark, let me change the color here. We can mark all these cells as 1. We can mark all these cells as 1. Others are 0. Okay, we can mark these 5 cells here and these 5 cells here as 1. Okay, these we can reach Atlantic Ocean because it's touching the Atlantic Ocean, obviously. Okay, now we go inside this other parts, and we see that what all cells can reach to Atlantic Ocean. Okay. So what should be the cells property to reach to Atlantic Ocean? It should be bigger than the adjacent element which can reach to Atlantic Ocean. Okay, so let's say 5 is big element and 3 is smaller than 5. It resists. Okay, so from smaller, like 1, it's easy, like it's the smallest element which can give you the path to go to Atlantic Ocean. It is the easier approach. Like 1 will be the first element which will say that okay, I am the smallest one, I am the easiest one, you can come to me and I will cross you to Atlantic Ocean, I will take you to the Atlantic Ocean. Then obviously these ones say that I will take you to the Atlantic Ocean fastest if you can come to me, I am the smallest. This 2 is saying that I am little big. So after these ones are, if you are not able to reach to 1, you can reach to me, and if you reach to me, I will take you to the Atlantic Ocean. And reaching to the 2 is easier than reaching to the 5 because 5 is bigger element, and if there is much bigger element, then also we can reach to 5. Only then if there is small element like 4, we can't reach to 5. So for this 4, we have the proxy to go to 2 and 2 to Atlantic Ocean. This proxy we have to get. Okay, let me remove all the drawings. Just a minute. Let me erase this only. Okay, so what comes to our mind? Like it's similar problem as the 3D rainwater. We are going from small to big. Okay, and if you can see that we have to process the smaller element first, and then their adjacent elements, then big elements, then their adjacent elements. So we always need that what's the smallest. We always need that we have a group of cells, and we need what's the smallest each time. Okay, what's the smallest element each time. We will keep adding in the group and keep removing from them if we have processed for this cell, and we need to know what is the smallest currently. So basic algorithm, like basic data structure comes in our mind is heap. If we say that we keep a min heap, we know that this is the min heap, and in min heap we can find the O1 time. From O1 time we can find the what is the smallest element, which is the heap cutoff. Top element is minimum element because we are keeping min heap. Okay, so let's try to solve using the heap with minimum, and let's take this one, like process this one first. So let's do a small try run based on the heap. Okay, let me just move this next. Okay, okay, let me change the color. Okay, so let's say we have pushed these 5 4 1 5 4 2 1 1 and 5. These are the bordering cells, and we have pushed these borders into this Atlantic Ocean ka Boolean wala set, and we have marked them as visited, and you can say this is a visited array. Okay, that from that we have visited and we can reach from there to Atlantic Ocean. Okay, and from all these bordering cells we push them into the heap. So in the heap we have 3 ones, so heap will be like 1 1 1, then 2, and then we have 2 4s, then we have 3 5s, 5 5 and 5. This will be like our heap. This is a top, this is a mini heap. Okay, so from this one, this one and this one we can't tell the where it is, so we have to obviously keep storing this x comma y coordinate as well. So we need x comma y value comma x comma y in the heap. Okay, and from this we have to keep it min heap. Okay, okay, so first we will remove this one from the heap. This is marked as visited. We will go to its neighboring cell like 4, which is already visited. We can go to 5, which is already visited. Its nearing is 3. So 3 is bigger than 1, yes. So it can reach to 1, yes. So we can mark this them as visited, and we will push it into the heap. So it will come some out here. Okay, so from this 3 we can reach to Atlantic Ocean. So we will mark this 3 as 1 here. This is marked here. Okay, all these bordering cells are already marked. Okay, and we have marked this guy also now. Okay, then this one's work is done. Then this one will come. This will say, okay, can I go to there? Yes, but it's already visited. Can I go to there? Yes, but it's already visited. Can this 7 come to me? Yes, yes, 7 can come to me. If 7 can come to me, then 7 can be go to Atlantic Ocean through 1. Okay, 7 is bigger than 1. Okay, so we can mark the 7 is visited. We will put it in the heap. It will come out as below, and we mark them as visited, and we can see that from 7 we can reach to Atlantic Ocean. So we will mark this as 1 visited. This cell is done, and we have pushed this. So after this work is over, we will remove this from heap. We like extract out, we pop out this one, last one remaining in the heap. We can say that neighboring cells 1 is visited already, 2 is already visited, go above 1. This is not visited. So can this 1 is bigger this one? Yes, or smaller or equal. So it's equal. So we can flow, it can flow to Atlantic Ocean. So we can mark this as visited. So this will be like visited, and we will push this one into the heap as well. So it will come top. Okay. Similar way, now this one will at the top. So from this one we can mark this 4 is visited because 4 is bigger, 5 is visited, 5 is bigger, 7 is already visited, done. Then from this 2 we can mark 4 already visited, this 4 is already visited, done. Then from this 3, now 3 will come. So from this 3 we can go to 4, so this will also mark as visited. Similar time we can like grow from where we can reach to Atlantic Ocean, and we can mark all of them as visited in this Boolean matrix. If we do this similar algorithm, we will apply to Pacific Ocean, and both the ocean we can merge the answers. So let's quickly code this. I hope you have understood this concept, problem, approach, and how to solve. So let's directly jump into the code. Okay, so first we will find that what's the height of, like what's the size of heights array, number of rows and number of columns. I will find heights of 0 dot size, done. Okay, and if n or m is less than 0, yeah, 0 means there is no cell, then obviously we have to return empty vector. So that's not the case, I think. Yeah. N comma n, at least 1, we have at least 1, so we can leave this. Okay, now what we have to do, we have to create two basically boolean matrices for Pacific Ocean and Atlantic Ocean. Okay, so let me create a matrix vector of boolean. It will be can reach to Pacific, so I name it as only Pacific. Okay, from these cells if we can go to Pacific Ocean, it will be marked as true. Okay, so Pacific mein I will add, like, it will be n comma m size, so I will add vector of boolean inside this m size, and all the values will be false at the starting. This is the initialization of Pacific array, Pacific matrix, and in the similar way we can create a Atlantic matrix as well. Okay, so we have created both of the matrices, which is initially false. Okay, now we can go to first row, last row, first column and last column, and we can specifically mark that what all the Pacific one and what was the Atlantic one. Okay, so let's go over. So if we are moving the I, we are like first column and last column. I am taking care of the columns, like first column is j equal to 0. Okay, j equal 0 and j equal m minus 1 will give you the first and last column. So first column will always go to Pacific Ocean, last column will always go to Atlantic Ocean, and obviously this corner guys can go to both of them. We have to handle that as well. Okay, so let's mark Pacific of I comma 0 is true, and let's mark Atlantic of I comma m minus 1, j is m minus 1 as true. So for all these guys I have marked as Pacific as true, for all these guys I have marked Atlantic as true. Done. For this first row we can mark Pacific as true, and for this last row we can mark Atlantic as true as well. Okay, so I will keep one more loop on j this time. So I usually keep I pointer for this rows and j pointer for the columns. It is easier in my mind map to understand and comprehend this. You can very well use any other naming convention here. So I will be like 0 for the first row, and I will be like n minus 1 for the last row. Okay, so here also I will mark Pacific of 0 comma j is true, and we will mark Atlantic of n minus 1 last row, and each column is true. Okay, so from this you can understand these two guys are already marked, like in this column, in this row. So when we are processing this row, this is marked in Pacific Ocean. When we are processing this column, this 5 is marked in Atlantic Ocean. So this 5 and this 5, these both corners are already marked in in both of the oceans. Okay, got it. So what we have discussed that we have to push this bordering into the queue. So let's first build for one. Let's build for Pacific. Okay, so let's create a priority queue. And we have to keep 3 things in this queue. We have to keep 3 things. What is this value? X coordinate, y coordinate. We have to keep these 3 things. So I am defining as a vector here, and vector of int. We have to keep these 3 things. Okay, this will be like Pacific queue. I named this Pacific queue, Pacific PQ. Okay, I named it. But here by default priority queue is makes heap. So we have to make it min heap. To make it min heap, we have to pass a comparator function which will say that based on this value, we have to make it min heap. Okay, so to pass a comparator function, we have to pass first a container. So container is vector obviously, and inside the vector we have a data type, and our data type is vector of int. This is our data type. Okay, now we have to pass a comparator function. So I will make custom comparator Okay, let's define this custom comparator on the word here. Okay, let's make it a private struct. So we will define a struct in this C++ struct custom comparator, which will be like this. We will be adding operator function here, which will operate on these two things. It will take vector of int as a value of a comma vector of int is a value of b. So it will take two vectors and it will compare and return our min heap. So for min heap we have to keep a of 0, like first element value is greater than a of 0. Okay, so now we have built this struct function, we have built this specific queue. Okay, so whenever we are marking the specific h2, we have to push this in specific queue as well. So we'll pass specific queue dot push. What we are pushing in this, we'll push that value is specific heights of I comma 0, and we will push x coordinate and y coordinate. This is specific queue. So I'm solving first for specific queue, and we will solve the similar way in Atlantic queue. Okay, here also we will mark as height of 0 comma j, x coordinate is 0, y coordinate is j. Okay, so now we have built a queue. Okay, from this queue, like this priority queue, this is a heap and mini heap. From this mini heap we can like pop out one element and we go to adjacent of them. Okay, to go all the four directions, what we'll do, we will make a vector of directions. So let me make it vector of direction of rows, which will be something like this, and we will make a column, so direction of column. And to keep this, like if we are keeping the row same, we can go up and down in column, so increase the column or decrease the column. If we are keeping the column same, so column will be like 0 comma 0, like we are not moving the column, we can go in the next row or in the previous row. Here we are moving the column, next time we are moving the rows. Okay, so we can go to next row by +1 and -1 in the previous to go to previous row. So we have these direction vectors. From these direction vectors we can move to all four directions. Okay, so I will implement this algorithm that while specific queue is not empty, we will go to this code. Okay, we will run, we will take this, let's say some temporary vector out from this pq. Let mark to temp as pq dot top. So we have, and then we can pop out pq dot pop. Okay, this is specific pq, so we will mark it specific pq dot. So from basic pq we have removed the first element, we have stored in the temporary. So here we have three values, like integer of value is temporary of 0, 0th element is our value, x coordinate is, let me mark x coordinate is temporary of 1, and y coordinate is temporary of 2. Okay, these are my values. Now I can go to all four directions, and to go to all four directions we will use this direction column and direction rows vectors. So I will loop into that. These are 4 sizes, so I can mark it 4. Okay, I can move to all four directions. So I will keep, like new row will be like, no row will be x plus direction of row of y. Okay, and what will be the new column? New column will be y plus direction of column of y. So from there I can get the new coordinates, like from where we have reached. Okay, and here I need to check 2-3 things. One, if we have reached out of the bound in the our matrix. So from this one, if I go up, I can go out of the bound. So I have to check is valid. Okay, is this cell valid first of all? If it is not valid, then we can't process this. Okay, if it is valid, then only we will process it. Okay, so if it is valid, to check this I will pass this new coordinates, new row and new column, with number of rows and number of columns in a function is valid function, and we will implement it. Okay, and what we have to check, we have to check it should not be visited. If it is already visited, then it can basically reach to specific question, then we don't need to push into the queue, we don't need to process it, because that's what will be reaching to specific queue anyways. So if specific queue maybe we have a specific matrix, in the matrix we can check if new row and new column already visited, then we don't have to process. So if it is not visited, then only we will process. Okay, and then if we are going from 2 and we are going to the bigger element like 3, then obviously from 3 to we can go to 2. So if the element we are going to, the new cell is bigger, then that water can flow to me, and from me it can flow to Pacific Ocean obviously. Okay, if it is smaller, like in case of 4, can this 2 reach to 4? No. Can this 2 reach to 4? No, because 2 is smaller, water of 2 can't reach to 4. Okay, so the element we are going into, that should be bigger than us, then only we will process, otherwise no, there is no need. Okay, so the new cell, the height of new coordinate where we are reaching it to should be greater than equal to current value what we have holding this value. Okay, so value we have temporary of 0. Okay, so it should be bigger. If all these conditions are true, if all these conditions is true, then only I will proceed. I will mark them, this new cell is visited, that this new is processed, this new location also, this location, water of this new location also can reach to Pacific Ocean. So I will mark as visited. To mark it visited, I will do Pacific of new row comma new column is true. My bad. Column is true, and we will push it into the priority queue as well. So in the Pacific PQ, I will push all 3 values, this heights of new row comma new column comma new row is a x coordinate and new column is a y coordinate. I will push whenever we are marking it as visited, we will push into the queue. Okay, we can look through this problem, go over. Okay, so one thing is remaining, is valid function. We haven't implemented it, so let's implement here. So it's a boolean function, boolean is valid function, is valid cell, int x coordinate, int y coordinate, int number of rows it will take, int number of column it will take. Okay, so if x is greater than equal to 0, and then x is less than number of rows, and then y greater than equal to 0, and then y less than equal to less than number of column, then we will return obviously true, that it's a valid cell, otherwise we will return false, that it's not a valid cell. Okay, so is valid cell, we can mark this. Okay, so by doing this, we have marked all the Pacific Oceans cells that we have created the visited matrix of Pacific Ocean. Similar, we have to do one more while loop, and we have to do for Atlantic Ocean. So to not repeat the problem, I will make an helper function here. I will create a void helper function which will help us, like I can call this helper function twice, once with Pacific Ocean, one with Atlantic Ocean. It can solve our deduplicacy of problem, like we have to duplicate this same thing, we do not have to do after that. Okay, so let me pass what all things it need our heights vector obviously. Okay, it needs our priority queue obviously, it needs our priority queue, so we will pass by address priority queue address, let's mark it as CQ, and it needs our boolean matrix which we have to mark. Okay, let's see its matrix. Okay, if we have these all 3 things, let me take this n comma n sizes here, and let's copy this code here from here. I can copy this complete code and I can paste it here. Okay, we have direction of column, direction of rows, specific queue is named as pq, temporary vector is pq dot top. Okay, whatever is the priority queue for Pacific or for Atlantic, we don't know. From both of them, it's the helper function, it will run the algorithm for both of them in a similar way. It will go to new column, new valid, it will check for valid cell, it will go to matrix. If matrix is not visited, it will mark as visited. Heights, we have passed heights. Okay, it's heights. And what we need to change here, this is pq. I think we have done our part. I think yes. So this algorithm will help us fill this complete matrix, and it will return the matrix. Okay, this is our function, helper function. Okay, so from here I can call helper function. Okay, it needs 3 arguments. It needs heights, so I will pass heights. It needs second argument as priority queue, I will pass specific priority queue, and it needs a matrix, like which matrix to fill, this specific matrix to fill. Okay, I will call the similar for Atlantic as well, so it will fill the Atlantic as well. It will be like Atlantic pq. Okay, one thing here, we haven't built the Atlantic pq, so let's copy paste it, and let's build the Atlantic pq as well, and after that we will do some processing. Okay, so first build this matrix, then we will do some processing. Okay, Atlantic pq we have not created here, so let's push some elements in the Atlantic pq. Similarly, this heights of I comma m minus 1, x coordinate is I, y coordinate is m minus 1. This is we have filled for Atlantic pq. Similarly, here we are marking as true, so we will be filling this here. Let me copy paste this. Heights of n minus 1 comma j, and here also n minus 1 comma j. Okay, so now we have filled both our Pacific and Atlantic queue. Atlantic and Pacific, both the matrix are filled. Now we have to make an answer vector. Okay, let's make this result vector, which is empty for now. So we will go over both of, we will iterate over this, and we will find wherever Pacific question true and Atlantic question true, we will push that index I comma j into the our vector, otherwise we will leave it. Okay, so I will process for all the rows, I will look through all the rows, and I will go over all the columns, and I will check if Pacific of ij true, and then Atlantic of ij. If both of them is true, then only I will push back this I comma j into that I comma j into this Pacific Ocean in the result vector, and I will return the result at the end. Let's run this. It is giving me some error. Okay, boolean operator expected. Okay, somewhere I missed something. I think this is the operator. I have missed something. Yeah, the struct I have to define it like this. Okay, somewhere compilation error, pq dot height. Okay, I have keep it height, it's heights as. Okay, it's saying pq.pop function is not there. Yeah, what the issue, like pq.not empty, pq.top, pq.pop. Let me check. Custom comparator does not provide a operator. Okay, so there is issue in custom comparator function. I think I have to, I call this like this only, custom comparator. Okay. I think to mark like this, custom operator work like this, and we have to mark them as constant as well, right? Some character, we have to mark them as const as well. These are like constants. Yeah, let's run. Both of the test cases are passed. Let's submit this. Yeah, it's accepted. So I hope you understood this approach of how to solve a problem, how to find an intuition that first we mark all the cells which will go to Pacific Ocean, then we will mark all the cells which will go to Atlantic Ocean, and we will merge both of them at the end. We will take a end operator, and to find this what all cells can go to Pacific Ocean, we go over the borders. The border can obviously go to Pacific Ocean because it's touching to Pacific Ocean, and then from this smallest border element, like smallest height, we can make it as a proxy that this is the smallest. If we can reach there, it's easy to reach there obviously, and if we can reach there, we can go to Pacific Ocean. It's a proxy route for us. So from there we go to all four directions, and we keep marking them and keep tracking the minimum element, and to keep tracking the minimum element, try to use the best heap solution. We have the min heap. There is some hiccups in this custom comparator function, but it's all now. I hope you found this interesting. Let's meet tomorrow then. Okay, bye.